All right, so welcome back. Today I wanted to just kind of go through an example of kind of graphing a polynomial function and finding all these different information. So the first thing you're going to want to do in a problem like this is, well, look at your function. Hopefully you have this like on a separate screen so you don't have to keep flipping back and forth. But um, so we're going to go to our graphing calculator and we're going to graph. Just skip there. So I'm gonna, if you have, so you press that y equals button to get to your graphs. That's like y equals. So anytime you're graphing something, you do need to make sure that the y is by itself or isolated. That's one thing that can be kind of annoying with these calculators. So you press that, it's below the mode button, but that x comma t theta n button, that's how you put it in x. Up to the fourth power, you should see a caret button above the division key. Make sure you bring your, in this app, I have to bring my cursor down. So I press the right arrow button to move my cursor back down. So minus 4x up to the third plus 3x squared plus 4x and then minus 5. So just be careful. I'm not sure, I can't remember. It's been a while since I've used an actual a real graphing calculator since we've been so long out of school. But I don't know if you have to move your cursor down when you're doing it like that or not. I think it might automatically do that, but I could be wrong. But once you've got this, you're going to press the graph button. Sorry about that. I was graphing it on a separate screen, so I would have it without having to flip back and forth. So this is our sketch. One thing, you can press the second graph button to get some points if you're trying to get a more accurate sketch. But to be honest with you, it really doesn't matter how accurate your sketch is. So kind of even ignore the scale on this. You just kind of want to draw a picture. Like if you didn't print this out, like just kind of draw what the shape of your picture looks like. So, I mean, it roughly looks something like this. And that is not accurate at all. So, I mean, you can graph it on this grid if you did print it out, but for me, it means nothing to me how accurate your sketch is. I mean, we're not really doing anything necessarily exactly with this picture. So your sketch really doesn't have to be super accurate, but you want to make sure you have the shape, like all of the curves and all the hills in it. So your shape needs to be accurate, but the scale does not need to be accurate really at all. Honestly, you don't even need a coordinate grid. But what we're going to do, we're going to go to our graphing calculator. We're going to find our max and our min. If you look on this picture before you go back, that we have a minimum here. Let me use a different color. There's a minimum down here. There's a maximum up here, and there's a minimum down here. And sorry, I should say that these are called relative maximums or minimums, or local maxes or minimums, because they're not actually the highest or the lowest points on our graph. They're just kind of the highest or lowest points kind of within kind of the main area of our graph before it goes up to positive infinity on both sides. So to get these in our calculator, so if you want to get your graph, you can just press that graph button in the top right, but you're going to press the second button, that blue button, and the trace button. You'll see above it, it says calculate, like in blue. So that's what we're going to, this calculate menu. So we're going to find our maximums and minimums. From what we saw in that picture, I believe we had a maximum first. Here, I can't remember, a minimum. So we're going to find this minimum first. So second trace, we'll go to option 3, or you can just press the 3 number. So it's going to ask you a few questions. If you don't see your cursor on this app, you can kind of just touch with your finger to move it around, or use these right or left arrow buttons below the graph button on your calculator. But when it says left bound, you want to make sure your x is to the left of that minimum, and then you want to move it to the right of that minimum. And then on this calculator, it's just going to give you your answer. In the bottom left, you'll see the minimum popped up. If it didn't pop up, like on a graphing calculator, it's going to say guess. Just press enter one more time, and then you should see this result. A few things if you're using an actual graphing calculator, any calculator like these, is if you get an answer that's like 0.000002, it's probably 0 because what your calculator doing is approximating these. The only way to really solve these, I was thinking about it the other day, like how would you solve these without a graphing calculator? You really need calculus. So if you do end up taking calculus courses, you would be able to do these problems without graphing, but that's obviously beyond the scope of this class. So I wrote down this minimum. So I'm going to go back to my picture, and I would label your minimum. So I'm going to round it just to one place. So that's negative 0.4, comma, negative 5.8. Then we're going to find that maximum. So I'm going to do second trace, and I'm going to do option 4. So I'm going to be left bound of that max, and then I have to be to the right of that max. So this max is approximately 1.4, negative 0.7. I'm just rounding it to one place. You depending on how accurate, you might want to put a couple places. I'm not too picky because we're not really doing anything like where we need to be incredibly accurate in here. But I mean, if you're doing some real world question, you probably don't want to round too much. But that coordinates of this point right here. You can see my sketch isn't very accurate at all. But like I said, it doesn't really matter because we're really just going to use these coordinates to help us get a lot of the answers on the right side anyways. All right, so then we got one more minimum to find. So we're going to do option 3. So I'm going to do left of that minimum and to the right side of that minimum. So this minimum, and like I said, it's 1.99998, negative 1.0000. That's just 2, negative 1. Like, so, because your calculator is just approximating, your calculator is not like doing anything intelligent. It's just running an algorithm. So it would be 2, negative 1. So the first thing I'm going to do is we found I'm just going to write these over here. So we found our minimum. We actually had 2 minimums, so I shouldn't write as big as I did, but luckily I could fit it. And then we had a maximum here. Okay, your domain is how far your graph goes left to right. So this graph is all real numbers. It's going to keep opening to the right, and it's going to keep opening to the left. So I mean, I'm pretty sure for all these functions, at least with like polynomials like x to the 5th, x to the 6th, x to the 7th, x to the 8th, like it should always be all real numbers for the domain for most of these. But just think about it just to make sure you don't get like a weird case or something, like a different type of function that isn't in this unit. But our range is how far our graph goes up or down. So you kind of want to use these coordinates. So the lowest my graph goes, I don't know if you can see, I'm highlighting here, down here. The lowest my graph goes is this y value. It goes from negative 5.8 up. So there's 2 ways you can write it. You can write it as an interval. It goes from negative 5.8 to infinity, or it's really y is greater than or equal to negative 5.8. Our end behavior, this first one is saying as your graph goes to the right, it's going to go up, or you could put positive infinity. As our graph goes to the left, it also goes up, or it goes to positive infinity. Increase and decrease in intervals. Okay, when you're doing increase and decrease in intervals, you almost want to ignore these y values. And crap, here, let me undo. I don't want to erase the function. So we're only looking at the x value. So like, that's why I just deleted the y values from those points. So you want to like start, you kind of almost, I would recommend you just kind of go left to right. So our function starts going down. So in terms of x values from negative infinity to this x value, negative 0.4, it's decreasing. But then from negative 0.4 to that 1.4, it's increasing. But then from 1.4 to 2, it decreases again. Sorry, I wrote really big. Hopefully I can squeeze this in. And then from 2 onwards, it goes up. So, and you should kind of notice these intervals always kind of continue one after the other. And you might be wondering, do we have to use like the square brackets for these? Honestly, no. Basically, I mean, I've seen in textbooks, some do, some don't, but I don't know what the difference is between increase and decrease intervals. I guess technically these n values aren't necessarily included because it's not necessarily increasing right at, like, for example, at 1.4, it's not exactly increasing or decreasing at a certain point. Since it's a turning point, it's not really included in the intervals. So just use round parentheses. But hopefully this video is a little bit better. But one thing I didn't really emphasize yesterday is how important it is to get a sketch. But your sketch really doesn't need to be accurate at all, like in terms of your coordinate grid. Just you need the shape of your graph so you can kind of see where it goes up and down, where it changes directions. But other than that, I mean, you really don't need this graph. If you want to be accurate, you can get those points. I mean, it doesn't hurt to be accurate, but at the same time, it's not necessarily a necessity for at least what we're doing.